Hey guys, welcome back. Just like I promised, I was going to show you how to do sliders. In the previous video, as you can see, we compared factored form to standard form. Now I'm going to give you the option to show you how to compare factored form to standard form, or show vertex form to standard form, or vertex to roots. So let's just go ahead and insert a new graph. Control, Doc, add a graph. Let's go ahead and hit Menu, View, and Grid, Line Grid. We just want to make this look as close to the paper as we could. Domain range opportunity. What is the domain being showed by the window? Domain is going from -10 to +10. What is the range being showed by the window? It's going from -7 to -6.67 to +6.67. Just quick questions, making sure that they're constantly talking about domain and range. All right, let's get to it. Let's go ahead and put in our vertex form. We learned from the other video that anytime we want a coefficient, we have to put it inside the parentheses. So we're going to say open parentheses, A, close parentheses, open parentheses, X minus H, close parentheses, we're going to square that, plus K. When we press enter, it's going to ask us, do we want to create a slider for H and K? Are you guys wondering why didn't it ask me about A? You're right, because you've already created the A coefficient on the previous document. And now if you had started from fresh, you would have had to create the A document slider. But for right now, we're just using what we got. We're going to make it do what it do, baby. Boo, boo, boo. Let's not state the obvious. Let's just do what we got to do. Awesome. So now that we see that, here's my equation for the, so what is the A value? I'm going to move this, escape to get out. Escape again, escape. All right, finally. So I'm gonna see the hand hovering, the arrow, hand hover. I'm gonna hold 1, 2, watch the hand close. And when I do that, the hand is closing on it. 1, 2, and I'm moving it up out of the way so I can see things. All right, so if we make H -1, look at where it is. Awesome. And what do we get if we get a negative times a negative? We get a positive, so that would be X plus 1. How would we write this? X plus 1. We still don't see A. Well, why don't we see A? I want to see A. I love people who want to see A. Menu. Actions. Hide show attributes. Set conditions, delete coordinate, redefine. Insert slider. We already have a slider that we want to see, so let's do here. See how we select A. It's already showing. Say OK because it's already been defined. Now you can see A. Are you happy now? Are you happy? You should be happy. So if I change A, make A, when I make A greater than 1, look at what happens. When I make A less than 1, look at what happens. Oh, that's a pretty thing. That's so pretty. Just got to think that's pretty. All right, so let's go ahead. We said we want to compare this to the other graphs. Let's go ahead and put in, let's press tab. I'm going to arrow up. And we want to see it compared to factored form. Look at that. How did we say we would be able to see the variables root 1? What did I say we would do? You're right. We go menu, actions. We come down here to insert slider. Which one are we doing? We want to see root 1. We say OK. Then we want to see which other one. Let's slide it down just a little bit so we can see what's going on. What other one do we want to see? Let's tap out so it'll unselect it. We do what again? Menu, actions. Come down here. Insert slider. It's already been defined, so we're just going to say root 2. We're going to say, okay, look at that. Yay, we have all of our roots showing. So right now I have my quadratic function in vertex form and I have root form. So I want to be able to write the congruency. I want to write where they're equivalent to each other, where they're the same equation, but the format is different. So let's see what I can do to change this. Let's change my root. Let's go. So we're getting close. Root 1 is positive 2. Which way do we need to go to make the root 2 go? Oh, don't want to go down. Up, go up. Oh, not working. Oh. It's going to be some tricky stuff, right? Where do we see 2 and 0 at? Root 1 is positive 2 and 0. Where do we see that at? Because right there is negative 2, right? But if root 2 is positive 2, that's x plus 2. If I solve for x, that becomes x equals negative 2. Exactly. Let's go ahead and change the vertex. Let's shift it down. Which one makes it move vertically? H or K? Did you say H? Let's see. Nope, he's not H. He's not H. He's not H. Let's go back right there. He's not H. So where do we want to go? It's got to be K. So which way do we want to go, up or down? So if we increase it, nope, we want to go down, and we know that K is equal to negative 2. So if we were to write these equations out in vertex form and factored form, we would then see that they are equivalent to each other. Guys, play with this. I really want you guys to get a chance to see and experiment and determine, do you believe this would be an asset for your kids? Let me know. Either way it goes, I just want to continue providing you with some tools for you to look at, for you to practice, and determine whether or not they'll help you and your kids. In the meantime, keep it real. Not complex. Get it? Real roots, complex roots. We don't teach complex roots in Algebra 1. We teach real roots in Algebra 1. So with that being said, let me at least give this a real root. Okay, we got real roots now going. Yeah, we got real roots. All real roots. Real roots, real roots, real roots. Keep it real.